All right, in this problem it says find the area of the common region to the polar graphs of r equals 2 and r is equal to 2 minus 2 sine theta. All right, so hopefully we are pretty familiar that radius is 2, that's this circle in polar form. So no matter what theta is, if I go out along that radian, I would get a radius of 2, and it goes all the way around. All right, so for 2 sine 2 theta, if I plug in radian of 0, I'm going to get that number right there, so 2. So if I think about it, sine of 0 is 0, 2 minus 0 is 0, so yeah, there's my radian. And then as I have more and more, plug in different radians, my radius comes from that function. So it doesn't look like they get very big, and then they get to 0. And so let's just see that. Theta is pi over 2. So, oops, what am I doing? If this is radius, plug in pi over 2 for theta. Okay, 2 minus sine of pi over 2 is 1, right? So 2 minus 2 times 1, so 2 minus 2, and that's 0. And then as theta goes on, it goes out here. As theta goes on, it's way down here. And it goes all the way around. Okay, what we want to find in this problem is what is the area in common. So the first part you have to figure out is where do they overlap? They overlap in this kind of weird looking, looks like kissy lips kind of shape, right? Okay, so it looks like that shape right there, but we get that if I'm starting at the pole and I go over, and I go over, and I go over, it's going to be, I get my radius from that blue function, which is 2 minus 2 sine theta. And then after pi, radian, if I go past that, it looks like I'm getting my radius from different values from r is equal to 2. Okay, the next thing I want to do is I want to use symmetry. So I know if I reflect this thing on the y-axis, it's the same on both sides. So what I'm going to do is I'm just going to try to find that. If I find that region, I just double it and it finds the whole thing. All right, so it looks like the intersection point is pretty obvious on this one. Where it changes over is at pi over 2. So is that pi. So here's the radian pi, duh. You might want to double check that, but I don't think it's really necessary. So this area is going to be equal to 1/2 the integral from, okay, so if I'm just doing it on the part that I have drawn, I start my theta when theta is equal to pi over 2. And I use that blue function, which is 2 minus 2 sine theta squared, that's my radius squared, d theta. And I use that, I'm going to use blue, and I use that theta, or use that function of r till theta is pi. So that's where I stop. And then I'm going to add that to, and I'm going to pick it up from using the other function. The other function of theta would be r is equal to 2. And I'm going to integrate that one from pi to 3 pi over 2. My radius is 2 squared d theta. Now, whatever I get, I'm going to multiply that by 2, right? And then that would be my answer. Multiply that whole thing by 2. Since I'm using symmetry, it continues on over here and right there. So we have to double that. Okay, the answer is going to be 7.708. Now, what I did the first time I did this, I'm going to show you an alternate way, is I'm going to start, and I'm just going to do the whole thing. I'm not going to use any symmetry, because sometimes if I use symmetry, I forget to double it, and that's unfortunate, but that's how it works. Okay, if I start when, I'm going to say area is equal to 1/2, and I'm going to start at 0, and I'm going to add up all these little sectors from 0 to pi, because that's where I use that blue function, which is 2 minus 2 sine theta squared d theta. And then I'll add Whatever I get, my r value comes from the other function, starting at pi all the way to 2 pi. So I'll say 1/2, starting at pi to 2 pi, radius squared d theta, and that would give me the exact same answer. One other way I guess you could do it is doing it starting at this theta of 3 pi over 2, using that and then going back around. I just don't think that's very good. I wouldn't do that way, but you could. So maybe I would go from negative, if I start and I could say, okay, from negative pi over 2 to 0, and I use that radius, which is 2, integrate that, and then starting at 0 to pi over 2, add those together, then double it. That's just another way. So several ways to do the same thing. As long as you try your way and you get 7.708, should be good. All right, we'll do the next question in the next video. So thank you for watching this one, and I hope it helped. Bye.